Welcome to another episode of Mastering Cybersecurity, developed by baremetalcyber.com. Let's dive in. Accounts and identities form a less visible kind of asset because they represent people and services rather than physical devices. Each user account combines a username, authentication method, and a set of permissions that determine what the person can see or change. Service accounts work similarly, but are used by applications or scripts to communicate with systems without direct human action. In a modern environment, there can be thousands of these identities scattered across email platforms, directory services, cloud consoles, and business applications. An asset inventory that includes identities helps teams understand which accounts exist, who owns them, and which systems they can reach. Without that view, old contractor accounts may linger long after someone leaves, still holding powerful permissions that nobody remembers. Forgotten service accounts can be even more dangerous because they often bypass typical login prompts and hold access keys stored in configuration files. Attackers who compromise one of these neglected identities can move quietly across many systems while appearing as legitimate activity. By treating identities as first-class assets in the inventory, organizations gain a clearer picture of who and what can act inside their environment. Data stores are another crucial category of assets because they hold the actual information attackers usually want to steal or alter. A data store can be a database server, a shared file system, a set of cloud storage buckets, or even a collaboration site where documents accumulate over time. What matters is that important records, such as customer details, health information, or financial transactions, are concentrated there rather than spread evenly across every machine. In an asset inventory, describing data stores includes noting what type of information they contain, which systems feed them, and which people or applications can access them. A community fundraiser might store donor lists in a cloud spreadsheet, while a small clinic keeps appointment histories in a dedicated database. If those locations never appear in the inventory, security teams cannot prioritize protections like encryption, backup testing, or stricter access controls. They also struggle to answer basic questions after an incident, such as which data stores might have been affected by a particular compromised account. When data stores are clearly listed as assets, it becomes easier to align security measures with the value and sensitivity of the underlying information. Logging is the practice of recording important events that happen on systems, such as logins, configuration changes, and error messages. These records, often called logs, help security teams see patterns, trace activity, and notice behavior that does not match normal expectations. For logging to be useful, however, teams must know which assets can generate logs, where those logs are stored, and how consistently they are collected. An incomplete asset inventory makes this difficult because some systems never make it onto the list, so nobody asks whether they should send logs anywhere. A forgotten test server, for example, might accept connections from the internet without ever recording who connected or what they did. When an attacker uses that server as a foothold, there may be no trail to follow, even if other parts of the environment log faithfully. Centralized log analysis tools can only work with information they actually receive, not with invisible systems nobody listed. By linking every asset entry to its logging status, organizations dramatically reduce these blind spots and create more reliable visibility into their environment. Patching is the process of updating software to fix known flaws, called vulnerabilities, that attackers might exploit to gain unauthorized access. Operating system vendors and application developers regularly release patches to close these weaknesses, but those fixes only help when they reach every relevant asset. An accurate inventory shows which machines run which software versions, so teams can plan patch rollouts in a targeted, organized way. Without that view, some servers, laptops, or cloud instances quietly miss updates, staying vulnerable long after others have been secured. A small company might proudly announce that it patched its main file server, while forgetting an older file server that still holds archived documents. Attackers who find that neglected system can exploit an old vulnerability and then move deeper into the environment, bypassing newer defenses. Security scanning tools can help discover missing patches, yet they still rely on knowing where to look and which assets exist. When the asset inventory and patching process are linked, teams can track coverage, flag exceptions, and reduce long-term exposure from forgotten systems. Shadow technology often appears outside normal information technology, IT, and people commonly call this pattern shadow IT. Employees often turn to these unofficial tools because they want to solve problems quickly, collaborate more easily, or bypass slow internal procedures. Examples include signing up for a new file-sharing site, creating an unmanaged team chat space, or building a simple web form on a public platform. Each of these tools becomes an asset that holds data, receives connections, and sometimes integrates with other systems. Yet nobody in security may know it exists. When shadow IT assets are missing from the inventory, they are unlikely to receive consistent logging, patching, or backup coverage. They may also fall outside normal training and monitoring, which increases the chance that risky settings or weak passwords go unnoticed. Shadow IT can appear in any department, from marketing to finance to small project teams running pilots. By including questions about unofficial tools in surveys, interviews, and onboarding, teams can gradually discover these hidden assets and bring them into the formal inventory. Once they are visible, organizations can decide whether to support, replace, or retire them with clear information rather than guesswork. Forgotten test and lab systems create another category of hidden assets that attackers often exploit, because these environments are typically built quickly and then neglected after projects end. Developers or administrators might spin up a temporary server to test a new feature, restore a copy of production data for troubleshooting, or experiment with configuration changes in a safe space. When deadlines pass, those systems sometimes remain running with weaker passwords, extra debugging tools, or open access that would never be allowed in production. If nobody records them in the asset inventory, they may never receive regular patches, logging configuration, or backup checks. A small retailer might keep an old test copy of its e-commerce site on a public server, still containing realistic customer data from earlier imports. Attackers scanning the internet can discover that server, exploit its weaker protections, and gain insight into the rest of the environment. Over time, these abandoned labs accumulate like digital junkyards, making it difficult for teams to know which systems are still important. By insisting that every test environment and lab server receives at least a basic inventory entry, organizations reduce the number of surprise systems that appear during incidents. Getting started with asset inventory does not require fancy tools or a large budget, especially in smaller environments. A simple spreadsheet or shared document can hold the first version, listing each asset with a name, type, owner, and basic purpose. You might begin with only a single department, a small clinic, or a community fundraiser, writing down laptops, key servers, important SaaS applications, and obvious data stores. Over time, you can add columns for logging status, patch coverage, and sensitivity, turning the list into a more powerful planning aid. The most important step is making asset inventory a regular habit rather than a one-time project that quickly becomes outdated and forgotten. Short, scheduled reviews help teams add new systems, retire old entries, and correct mistakes before they cause confusion during stressful events. As the inventory matures, it becomes easier to explain your environment to auditors, partners, and new team members in clear, grounded terms. More importantly, you gain the confidence that comes from knowing what you actually depend on before you design defenses. This has been the Mastering Cybersecurity podcast, developed by baremetalcyber.com, sharing practical guidance to help you build safer environments. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.